Okay, so do you know what Neil deGrasse Tyson, Larry Page, Elon Musk, Goldman Sachs, and Luxembourg all have in common? A strange grouping, I know, but they all believe that the world's first trillionaire is going to be an asteroid miner. Okay, second question. 1969. What does it make you think of? Well, it's the year Neil Armstrong landed on the moon. 5 years later, Gerald O'Neill, a professor in physics, argued that building a colonization in space was already achievable, even using 1970s technology. He justified his argument by detailing that it takes less energy to reach near-Earth asteroids than it does to the moon. This is due to asteroids' low escape velocity. And then the first interplanetary mission, which successfully landed on an asteroid and returned home, was in 2004 and performed by the Japanese Aerospace Exploration Agency. It's famously known as the Hayabusa mission. Since then, Hayabusa 2 was deployed in 2016 and is set to arrive back later this year with samples, with NASA believing that 1,500 asteroids are easily accessible. A huge political motivation for working out this technology exists, and mining asteroids is becoming more and more feasible. The first issue tackled is increasing scarcity of Earth's resources and the supply risk and political uncertainties associated with a number of these resources. As the global population is increasing at an unprecedented speed and scale, it is imperative that we find alternative sources. In fact, just one asteroid holds more than the entire supply of platinum ever mined throughout the history of Earth, worth $50 billion. And then Davida, a near-Earth asteroid, is considered the most valuable asteroid in the asteroid belt, with a resource value of $27 quadrillion. This is 27 million with 12 more zeros. The rare earth metals, which asteroids are so abundant in, are used today in key sectors, namely for green technologies, such as fuel cells, high-capacity batteries, and solar cells. Due to technical advancements in astronomy and deeper mining efforts, we are edging closer to a time where it may be cheaper and more environmentally friendly to mine materials from outer space and bring them back to Earth than to take them out the ground. In fact, in 2019, a life cycle analysis estimated that in-space mining generates substantial less environmental impacts compared to some mining activities on Earth. The company Deep Space Industries envisions a 4-step process: prospecting, harvesting, processing, and manufacturing. Tiny space probes go out and search for resource and water-rich asteroids. The resources are to take home, and the water is to be broken down into oxygen and hydrogen, which can then be used as a fresh water supply for the astronauts, but more importantly, as fuel used to propel themselves home, significantly reducing the cost of travel. So, how easy is the harvesting process? Asteroids are considerably smaller and lighter than planets, making them much easier to mine as their heavy metals stay near the surface. It's the destiny of density. Recent discoveries in mining by NASA, known as the Mini-B mission concept, concentrates large quantities of sunlight into small areas onto the surface of an asteroid using these inflatable solar concentrators. This process breaks up the rock, meaning we don't even have to touch the surface of an asteroid to mine it, overcoming microgravity issues. Using this technology, the market value of asteroid mining is estimated to increase from $712 million in 2017 to $3.9 billion in 2025. This is a 440% increase. The legal factor is what makes asteroid mining complicated. Legally, nobody can own an asteroid, with the Outer Space Treaty signed in 1967, preventing any nation from claiming land in space as its own. In 2016, however, Luxembourg developed a legal framework so that private companies can be entitled to the resources they mine from asteroids, but not the asteroids themselves. However, this makes you wonder if us humans even have the right to mine what isn't even our planet. This is where the 1/8 principle comes in. Basically, we should leave 7/8 of the solar system to the wilderness throughout the future of humanity. 1/8 is only 3 steps away from complete exhaustion of the solar system's asteroids. To summarize, investment in space ventures have been steadily increasing. In 10 years, we will likely be launching our first asteroid mining vehicles to bring back quantities of resources. In 100 years, it's quite plausible that there will be people living on the moon in giant structures made from materials mined from asteroids. Goldman Sachs quoted, "The psychological barrier to mining asteroids is high. The actual financial and technological barriers are far lower."